But before we begin, I think that some introductions are in place. My name is Magnus Clausson, and I'm the team lead for one of the development teams here at Forefront Consulting. And this evening I have with me Jenny Sten and David Hedman. Jenny, would you like to introduce yourself a little short?
Yes, my name is Jenny Sten and I'm a software developer at Forefront, and I've worked here for 4 years.
And David, a little bit about yourself?
Yeah, my name is David and I'm a cloud architect and developer as well, and I have been working here at Forefront for about 9 years and have been a consultant for whole my career, which is about 15 years.
Excellent, thank you very much. We'll be hearing more from David and Jenny later on in the presentations, but as of now I would just like to add that due to COVID-19 restrictions we're not able to have you all here at our office, but the speakers and I will monitor the live feed, and if you have any questions just write them there and we'll try and answer them as good as we can. So I'd like to present a little bit about Forefront Consulting. We are a consultancy firm with about 400 employees, and we work within 3 divisions. We have the channels divisions, where we do service design, user experience, and the modern workplace, and the management division, where we do IT management and enterprise architecture, and the technology division with system development and analytics in the cloud. We focus mainly on cloud transformation, business agility, and analytics. And here in the technology division, which I represent, and David and Jenny as well, it's all about tech and teamwork. And today we'll be focusing on modern application development, and specifically the Azure platform and how you can use modern cloud architecture to evolve your applications in the cloud. And a little bit short about our agenda for this evening. We've had a short introduction now, and then we'll be listening to Jenny's presentation, and we'll have some questions afterwards with the panel, and we'll move on to David's presentation and some questions after that, and then we'll wrap it up a little bit later. Now, I just said the opposite of the agenda, didn't I? I'm really sorry. Sorry, it should be it should be David's session first and then Jenny's sessions. I'm sorry for that. So, just a couple of rules for the session, so that you all know how we work it out. All the presentations are pre-recorded, and we, the speakers and we'll have a panel here with questions and answers. So just shoot your questions in the live feed, and we'll pick them up. And if there is any questions, just use my email address, magnus.clausson@forefront.se, to get in contact with us for any further discussions. So, with that little introduction, I would now like to move on to the first presentation done by David. So, enjoy.
Hello everyone, and welcome to my session tonight. My name is David and I'm a cloud architect, and I have been a consultant for all my career, and that's like 15 years or so. And I have been working with Azure since the dawn of time, when Azure was released for 10 years ago. But as an architect, I find it very good to still code, so I still love the coding parts. And when I'm very passionate about software craftsmanship and the quality that comes with the software craftsmanship. And I'm also very fond of the solid principles. And as a developer, you need to have a favorite principle. And here my favorite principle is O, that is the open-closed principle. And how does an ordinary day look for me as a cloud architect? Actually, I have several customers at the same time, and some of the customers I advise in Azure-related questions, and some other customers I'm very hands-on and writing POCs and stuff like that. And at other customers, I dig more into the code. Those customers have come a bit further than the other customers, so there I can work with infrastructure as code, and I usually use ARM templates or Terraform to set up the infrastructure via code. At some customers, I'm also some kind of quality assurance person, and then I often consult system development teams in how they should set up their architecture or how they have set up the architecture. So let's move on to the more interesting parts of the evening. First, I'm going to talk about how Azure has evolved during time. Back in the days, before there was Azure, we just moved to virtual machines. Actually, that was a real big step forward, to be able to have a virtual machine instead of on-prem servers, that is physical servers. So the virtual machines was a very good thing, according to my opinion. But when Azure came, then they moved those virtual machines to Azure. This wasn't really cloud. They just hosted the virtual machines in the cloud, but that wasn't real cloud. So when the Azure services came, this was a giant leap towards setting up more serverless architecture. So very many of us moved the virtual machines and took the applications and hosted them in app services instead. And this is cloud-ish, according to my opinion. You need to go even further and beyond the app service only. And that's what we're going to talk about tonight. So how do you move beyond the app service only? I think it's a very good approach to start with a simple service like an app service, and then you need to iterate the architecture all the time. You need to iterate the whole solution. Another thing that is very important is to know which services is related and know how to combine those related services. Because a lot of the services are quite similar, but they handle the problem in slightly different ways. So it's very important to use the right service for the right type of problem. And here we have a link where we can see all the services, and you get a description of how the services works. Here is a website which lists all the services, and you get some information about the services. It is also very important to know, as I said before, how to combine the services and get some architecture from them. So actually we have another link where Microsoft has provided some kind of reference architecture for how you can combine all the services in a very good way. And I will provide the links to those sites in the presentation. It is also very important that you do not overuse the services. I have seen development teams that just use the services because when Microsoft releases some kind of new cool service, a lot of the developers just want to use this service just to try it out. But please do not do this. Use the correct service for the right type of problem. If you want to use a new service, then you can have some kind of proof of concept, or even better, if you have some kind of private project you're working on where you can try the service out. Another thing you should not do is try to do a big bang. And with big bang, I mean to try to set up the architecture all at once. So please, instead of a big bang, you should iterate the solution all the time and drive the architecture forward by iterating it. And how do we plan to move the legacy applications to Azure? Often I use a three-step model for this, and the model looks like this. First, I define a current as-is state. This is the current state for the system or the application or the applications, if you have several applications. And then I define some kind of visionary or strategic to-be state. And this state is where you want to have your application or your system in like 1 year or 2 years. This is actually, there isn't a silver bullet. You can have the same to-be state for all your customers, all your applications. You need to define a single to-be state for each applications that you want to move. After this, we have the transition phase, and this is where all the magic happens. This is the part and the phase where you actually start to move your applications to Azure. And now I will talk a bit more how we use these different states. As I said, in the as-is state, we define the current state of the application or the entire system. When I'm working with defining the as-is state, I also find external integrations. And external integration, it don't need to be external API calls or something like that. It can be calls to external databases or even internal database call. And then I try to find seams in the system. And with seam, I mean some part of the system where you can tear the system apart to get more handleable, loosely coupled parts of the system. And this term seams, it came from the test-driven development. And in test-driven development, the seams are parts where you inject interfaces to create more decoupled solutions. So I take this concept and introduce it when I'm working with Azure architecture as well. I also identify applications that we can move, but also those applications that we cannot move. And it's also very important to identify applications that are not worth moving. And this can, for instance, be an application that soon will reach some kind of end of life, some contract that will not be renewed or something like that. In the to-be state, I defined the strategic and visionary, what I call a target condition. And then examples of target conditions can, for instance, be a solution that can scale infinite when new users are added, or it can be an autonomous service that can be reused by any other application, or it can be some kind of plug-and-play platform where customers can add their own applications. So it's important to know that the target condition is different for each application. And it's also very important to know that the target condition probably never will be reached. This should be some kind of guidance where you should steer your architecture. And the reason for why it never will be reached is because the requirement will change all the time. So maybe it will be reached, but not the target condition that you define here and now. And then it's time for the actually transition. And as I said before, it's in the transition where you code all the parts, you create the new services. So it's here that the magic happens. And you need to have some kind of plan. You can't just run to your computer and open Visual Studio and start to code. But please do not overwork the plan. And with overwork the plan, I mean do not just sit down and draw fancy architectural diagrams and stuff like that. Diagrams are very good to have when you're working with architecture, but they very often get outdated very fast. And those diagrams actually can be generated by Visual Studio, or you can generate those diagrams from within Azure. So according to my opinion, this is a better approach, to let the code generate the architect diagrams for you. And also very important is to not have an ivory tower approach. And with this I mean you shouldn't be an architect that sits in your tower and look out over the landscape, and then sometimes you climb down from your tower and go out in the landscape and talk to some people, and then climb up again in your tower and draw your fancy diagrams. The thing you should do is to attend in the daily work. You should be a part in the team. And with the team, I do not just mean the developers. The team is greater than just the developers. It consists of the product owners, the UX people, the testers. Even you can see like a CEO can even be part of the team in an economic way. Further on, you have the transition, and I said it before and I say it again, that I don't think that the big bangs will work. That is, you take the whole application and try to implement it all at once. Instead, you should assess the architecture all the time and try to continuously improve the architecture. I usually compare the architecture with a garden. If you don't mow your lawn or cut your trees and bushes, it will grow wild. And the same thing applies to architecture. It will grow wild if you don't assess it all the time and work with continuous improvement. And of course, this applies to all architecture. This is not just cloud architectures. And another thing that is important to know is that when working with legacy application, you will come to the hybrid solution. And a hybrid solution is an architecture when you have some part of the application in the cloud and some parts of the architecture on-prem. And often it is the database that needs to be on-prem, maybe for Swedish companies, and some of the companies need to have their data stored on-prem because Azure today do not have any data centers in Sweden. And I guarantee you that this will happen when working with legacy application. So you need to have a solution for those kind of hybrid solutions. One tip from a coach, I would call it, is to, if you haven't worked with event-driven architectures before, I think it's a really good solution to take a look at these event-driven architectures. Later tonight, we will hear Jenny talk about event-driven architectures and how they even can increase performance in your Azure architecture. And of course, everything new you're building or that your company is building, you should build it in Azure. I also need to say something about security management. Actually, this is a completely different talk, but I need to mention something about security. Just putting an application in Azure does not make it secure. All security rules still applies. So as a developer, you need to think about security. And in Azure, every application handles its own security. It's not like in the old days when you have an on-prem solution with a network around all the applications. That was before. Now when we are working in Azure, you need to have the mindset that the application handles its own security. It is also very important that you apply all the recommendations from Azure Security Center. The recommendations are not silver bullets, but it will make your application more secure. Another thing you need to know about is the cost that comes with Azure services. The same service, but in different tiers, can have a very different pricing. This, as a developer, can be very good to know. So you shouldn't just spin up a lot of new services, because this can become very expensive. This is also a completely different talk, but I just want to mention this in this talk. So, to round up this evening, I will provide some good links. We have looked at 2 of them before, and I also have added a third link. First, we have a link that lists all the services in Azure, and you can get descriptions of what they do and how much they cost. Then there is a link about architecture and how to combine Azure services. And the last link is a link for Azure updates. Here, Microsoft lists all the updates that comes to Azure. There are new services added, and improvement of existing services. So this ends up my talk tonight, and now we shall proceed with Jenny's talk about how they have implemented an Azure architecture in an event-driven way. Thank you very much, and see you soon.
Glasses on and focusing on that very toolbox. What is a more common feature or area you assist your clients with in Azure when doing proof of concepts?
Yeah, that's a very interesting question. Often when I do proof of concepts, I take a big problem and chop it up in smaller pieces. One example can be that we should migrate some kind of larger system into a kind of more event-driven solution with maybe a queue or a topic or something like that. And then we just take a little part of the system and write a proof of concept that we can show that the actual concept is working the way we want it to work.
Problem solving.
Yeah, exactly.
Yeah.
Yes, take a large problem and make it smaller and work on the small pieces instead of one large problem.
Yeah, that is the most easy way to work with bigger issues, I presume.
I have one question from the feed here. It's from Edwin. I was wondering about the POCs you define as a way to innovate.
I think that was a good
Oh, that was the one. That was your question.
Yeah.
Sorry,
that was the one.
Okay.
But if we want to make it super clear for Edwin.
Okay, we'll take it one more. Okay, so that was for you, Edwin.
But one question I was thinking about, that was super interesting. You defined there in an early stage about the solid principles.
Yeah.
And you defined the O as your favorite over the others. Could you explain why that is?
Yeah, actually all the principles are my favorite, but O is the favorite. Because O, I think when you're using the O principle, you get to code that is more dynamic, that you can write code without if-else statements or switch case statement, and you just can add a class and write unit test for that very class instead of the actual logic that is introduced when you have if-else statement. So it becomes much more cleaner code for the entire system, and it becomes much easier to work with the entire system when you use the O principle. And when you use the O principle, the need for the L principle is less. And I have seen that very many struggles to implement the L principle, the Liskov principle, that is.
Yeah.
So Jenny, do you agree with David about the O principle, or do you have another favorite?
Well, I like the O, but I think the I is my favorite, and perhaps the S as well. I like the I in terms of what's in interface segregation and being able to split the solution also in terms of testing to really keep it clean and be able to mock the interfaces when you unit test stuff. As well as, I love structure in code, so therefore the single responsibility.
It's good as a developer to love structure, isn't it? Great.
This should be part of the fundamentals when you're actually learning to write code, I presume. Like in a very early stage that you get this structured way of doing things and solving problems, of course.
Yeah, I agree, 100%.
100%. Another question, is that about a month ago, we had another webinar here regarding modernization for effective product teams. We talked about the journey, you could say, while modernizing your application, how you can reach value in an early process there as well. What would you recommend people to think of in an early stage, like moving legacy to the cloud and modernize your application?
This is a quite big question, but my first recommendation would be to not to what you said. Do not over-architect too much. Get to the actual problem and implement the code and create all the services and stuff like that. So do not over-architect and
And really focus on the value that you want to deliver, and not we want to do this and this and this and this, but start with the small pieces and okay, can we deliver this to the clients? And
talk is cheap.
Talk is cheap.
Yeah.
Yeah.
Yeah, but a little bit that I said before, to cut the problem in smaller pieces and start with one piece and actually get this piece into production, and then you take the next piece. Do not perform this big bang. Perform it piece by piece instead.
And of course, define an architecture that will support that kind of behavior.
Yeah, exactly.
Okay.
Yeah, not all solutions fit everyone's problems, of course.
No. And the initial problem is most likely going to change along the journey.
Yeah.
And you're not going to find it out if you don't try.
And then you'll need a platform that is designed for that to happen, even when you run into problems.
Yeah.
Okay, good. Should we sum it up with that for David's session? Or are there any more?
Sure, yeah. We have some incoming sessions that will be super interesting as well.
Yes, great. So I would like to now lay it out for the next presentation. That is the presentation of Jenny. So the meetup stage is yours, Jenny.
Before that, a little bit about me. I'm a software developer at Forefront Consulting, and I started out as a trainee in 2016. And what made me really fall in love with this occupation and keeps inspiring me every day is software craftsmanship. And the best feeling for me is when you have received a tricky problem and you put it on the table, you discuss it with your team, start breaking it down, and in that way realizing the solution with high quality. Now that you know me, let's jump into the case of the day. And this was the starting point for this customer case where, this was basically what was set up when our team first came in contact with this customer. They had a front-end application on an app service, as well as a back-end application, an API, also on an app service. And these were indeed in the cloud. However, the back-end contained multiple different functions, often entangled in one another. And the backend didn't own any of its own data. It consumed it from multiple on-prem data sources or external data sources, because the backend contained multiple different functions. So it consumed the information from different data sources. So I'm going to focus this presentation on what we have done backend-wise in terms of taking this backend API service into a microservice architecture, and with that creating a solution that is more secure, performant, and available. So let's get started and talk about the microservice architecture. The very first thing we did was to get an idea of the functions currently in the old application. So we made a domain model of the functions and the logic in the current application and extracted the present logic from one of the functions, the most critical one, and moved it into an app service of its own. So what you see here is the case where we have done that. And after that, we started pinning down the pain points in the current solution in order to make the solution more performant, available, and secure. And the first pain point that we addressed was the response time, the end users reporting a sense of a slow system. And we did that as well as the constant dependency to other system and the possibilities of what we could create always being restricted to that on offer by the system owning the data. And with that, we moved to this. And the first thing we did was to get rid of the synchronous behavior when retrieving the data. As you can see, the procedure when sending updates is the same. The post and put requests are made directly to the app which owns the data. But instead of retrieving the data directly from the on-prem application, we instead retrieve it from a Cosmos data store. And this Cosmos data store basically holds a replica of the data in the on-prem data store. And the data enters the Cosmos data store by a set of steps, and it starts by an update in the external data store or on-prem data store, which then sends an event via HTTP to a function, which we have decided to call worker. And this function retrieves the event and puts it on an internal service bus queue. It is then caught by another function, which triggers on a service bus. This function validates the event and maps it to the microservice domain model, and then puts it in the Cosmos data store. So this ensures that we always have an replica of the latest data in our microservice. Since we now can retrieve data from the Cosmos data store and don't have to call upon the external data store, this reduces the time it takes for the end users to retrieve the information. Additionally, if the owner of the data, the on-prem application, were to suffer from downtime for any reason, then we can still expose the information to the end user, even if he or she cannot act upon it in the current situation, making the solution more available for the end user. Another thing that we also can do when the microservice contains its own replica of the data is make use of the data in a way more desirable for our end users. In this specific case, there was a demand for querying among a large set of data in different ways. So what we did was not only store the data in Cosmos, but also put it in Azure Search, giving us the availability to query among the data. So already with this, we have a solution more performant and more available than the previous situation. So what we did after that was to get rid of the synchronous behavior when sending updates as well. So the API no longer communicates directly with the on-prem data source to send updates. Instead, it puts a message on the internal service bus queue. And this is then called by a function, which in this case we decided to call a writer, which takes the event and maps it to the format of the application which owns the data, and then sends the request to that data source. So the API do not have to wait for the response for the on-prem application as it had to previously. And so we have taken another step towards performance and availability. The API simply responds with in this case, we have done it with it responds 202, so that it has been accepted. And then it's up for the consuming party to decide what to do next. But the consuming party knows that the request has been accepted and is going to be dealt with, but we don't know when. As some of you may think already, what happens when something do not go as planned when the writer sends the request to the owner of the data? How do we signal that to the end user if we already have responded with that we have accepted the request? And that leads us on to the next step, which is where we have made use of Signalr to push updates to the end user. So if things weren't to go as planned for some reasons, in the writer, it puts a message on, once again, on a service bus queue. And this we do as well when the worker has received an update on an event. In both these cases, we put them on the service bus queue, and these are dealt with by another function, which is called a pusher. And this pusher pushes the event to Signalr. And Signalr can be described as a sort of like a chat room where each end user currently logged in has its specific chat. So once the user logs in, it connects to a Signalr Hub, meaning it gets its own chat room. And let's say that this microservice were to represent products in a web shop, and the user in question is clicking a button to purchase a given product. However, when the request reaches the writer, which is going to send the update to the store to take this lost product, somebody else has just purchased it. So the writer gets the response that the purchase cannot be made. It puts a message on the service bus queue, which is received by the pusher. Now the pusher can then, based on the ID of the user, which was part of the request, it can push a message to that specific chat room for that specific user, meaning the user currently logged in quickly gets the response that this purchase could not be made for some reason. And you can also make a group of chats in Signalr. If there are 4 end users currently looking at a specific product, and with the same case, the final product just gets purchased, so there are no available products to purchase at the moment, then we want them to receive that update, which the on-prem application has just sent to us, that the stock has gone from 1 product to 0 products. In that case, all the end users currently logged in looking at a specific product are part of the group looking at that product, meaning Signalr can, or the pusher can push a message to Signalr for that specific group, for that product, meaning all the users quickly get that response. Before we introduced Signalr, the ones consuming the microservice had to long poll it with an interval of, well, any given that you have, in order to retrieve the updates in the data, or to know when there are any updates, which was not as time efficient. And this is basically where we are now with our microservice architecture. And I have explained it in, well, 3 steps, but really it's been like 100 steps, where multiple times it's been 3 steps forward and 1 step back. So we have iterated this solution to come up where we are now. And as I said, this is an example from one of our customers, but we have done this in a similar manner at other customers as well. I'm also going to step into a bit on what we have done in terms of authorization on these microservices. If we step back into the starting case, the front end in this case was consumed by different types of users. And in order to access the front end, the user had to log in. And the token returned, which was from an identity server, it returned the roles used to access information in the API. Now that, let's say that we have our microservice architecture in place for multiple of the functions. So we have taken them from the old application into its own microservice. And we have 2 different types of users. Now, the information in each microservice is to be consumed by multiple types of users, but we wanted to make the microservices unaware of the end users, mainly because we felt that there was a risk for the domain and also the API models in the microservices being colored by the end user's need rather than the domain itself. Additionally, we wanted to stop the end user from accessing the microservice directly. So what we did was that we introduced a layer of authentication in front of the microservices. And if we take the same example as we did previously with a web shop, let's say that our Microservices in this case represent products, offers, and members, and our end users are a customer and a salesperson. They both have an interest in consuming the information from the microservices, but the salesperson being employed at the company should be able to see more of what is in the microservices than perhaps the customer should. So if we step into the authentication layer, we made the authentication layer aware of all types of users and all types of microservices and the roles which the microservices accepts, which is not salesperson or customer, but roles based on the domain in the microservice. So for example, here we have the microservice products, which have the roles get available products and get upcoming products. For let's say that it has 2 endpoints to retrieve these different types of information. And these are the roles that are granted access to these 2 endpoints. In order to access a microservice, a user has to pass through the authentication layer, and it does so using the token which was used to log in from the identity server. And this contains the role of the user, so for example, customer or salesperson. Based on that and the microservice the end user is requesting to access, a new token is generated using Azure Key Vault with the roles in the microservice. So let's say that the customer logs in, it passes through the authentication layer to access the products, and in the authentication layer, it then receives the role get available products. Now, if a salesperson does the same thing, it receives that role, but also the role get upcoming products, meaning it can access both endpoints or both types of information when the customer can only access one of them. In this way, it's easy to add a third end user role without having to make updates in the microservices. You can simply add it to the authentication layer and from there say which microservices this user should be able to access, as well as which roles it should have. And that's all for me. Thank you.
Welcome back to the studio. And thank you very much, Jenny, for a great presentation. When we were watching it, I got the feeling that it was a really smooth ride. You know, you had all the services lined up, and then you just continued on. But I have also, maybe there were some problems during the way. Could you talk a little bit about that and maybe how you mitigated them or something about your teamwork?
Well, I mean, it's not always a smooth ride, as I said. Many times it's a couple of steps forwards and 1 step back. Mm-hmm. And the first microservice that we built, we actually killed, but took down a couple of months ago. And one part of that was because we felt that the scope for that microservice wasn't correct, the function that we built. And we also had a lot of discussions whether we were going to replicate the app owning the data, that format of the data right away in our Cosmos data store, which we started with, but then we felt like, no, we need to create our own domain, our own representation of this data according to the user needs and the business needs. Okay. So that was something that we stepped away from as well. And I think one thing that many do is make the functions too big. Mm-hmm. It's like, okay, I want to react on this event and I want to do this and this and this with that event. And the functions can usually get like rather big rather than having several small functions acting on the same event and doing what they should with that.
Which somewhere is one of the main purposes of using this sort of architecture, I presume.
Yeah.
Like,
sure. Yeah. And regarding, you know, the team, the decision making, how do you set it up? How do you work? Do you work together, or do you have someone making the decisions, or how do you do it?
the customer where I am now, we've had the luxury of having an architect like in each team. So it's mainly the architect having the initial discussions with the product owners and try to like see a couple of months forward what is coming up. And then the architect together with the developers start talking, as David said, how we're going to solve this problem and how we're going to do it. So, well, I mean, it's usually a bit of a playground in the beginning, and you try and find a way and you test, oh, this is going to work, this is not going to work, oh, this is going to be great, but we forgot to think about this thing. So, yeah.
And David, do you have any similar experiences?
Yeah, one thing I think about is when you talk about if it is a smooth ride, it always in the beginning I have felt it feels like a smooth ride, but there is some kind of tipping point when you can't just deploy microservices into new app services. You need to have some kind of way to handle the whole microservice architecture, because otherwise it can become very expensive and it's very hard to approximate your costs, and then you will end up one day having like 60 app services in one app service plan, and this will become a problem. So there is some kind of tipping point, but there isn't a silver bullet that you can say that like 20 microservices or something like that. But there is a tipping point where you need to have some kind of solution how to handle all your microservices. And my suggestion is also to have some kind of service discovery, which is a repository where you can find the services that already exist. And you can ask this service discovery repository if there exist services for this or this or this. So this is also a thing that I have noticed, that this is very, very useful when you work with microservice architectures.
Okay, great. So, Gustav,
so difficulties in terms of costs, obviously, but also in terms of the scope can get a bit broad if you don't have any like management over that. Well, building this very feasible architecture, but all the sub pieces can be a few too many if you don't have, I would say, boundaries, but some sort of limit over something. All right.
Gustav, any questions from your side there?
We have one question in the feed from Malin here.
You can go.
I think it's directed towards you, Jenny. You started out as a trainee here at Forefront, and now you are a solution architect. How has this contributed to your comprehensive knowledge about software development and not to mention architecture, solution architecture?
I think it's been, I mean, we are like the first 3 weeks when I began at Forefront, we were 10 trainees and we were here for a month, and basically just getting to know the culture, all the different divisions, getting to know each other and the company, which made us a really good team, and it was a really good start when you came right away from school to get this group of people that were in the same stage, and so that was very nice. But then in terms of what I've learned, I mean, we've had education like I don't know, like once a month, in terms of how do you say, consultantship? Yeah. And then once a week we've had coding education with more experienced developers at Forefront, where we have talked about stuff like solid, clean code, basically software craftsmanship. So together with that, and then being out on the customers, working with experienced developers, being able to try these things that you learn and make mistakes, but like in a sort of secure environment.
Yeah.
And then occasionally stepping out of that.
Trying your own wings.
Yeah.
Okay, great.
I'm curious, what is good software craftsmanship according to you?
That's a tricky question. But in my opinion, it's when I leave work, when I go home, and I have a feeling that I have written code that is well tested. It's basically it holds all the solid principles, and I know that another developer coming into looking at this tomorrow is going to understand what I've done and know how to take it further. That for me.
Gustav, do you agree?
As good as any.
As any. And David?
Yeah,
what about
actually,
yours?
there is a manifest for software craftsmanship where you can sign it, and I totally agree. It is you should, as a developer, you should be proud. You should be proud over the code that you write. You shouldn't just write it. You should be proud, and it should be very easy for other developers to read your code and to get into a new project and just sit yourself down in front of the computer and run all the unit tests and know that, this code is working.
What do you think is the greatest value for other people in code when you agree to the principles? What does it make? What is the greatest value that it spreads, sort of?
It creates a community for other people, so that you know that there are other people that want to write good code. So it creates some kind of community of very skilled developers.
Yeah. Do you think that you have yourself, had some? It's been somewhat of a easier journey for you as a system developer, coming from the solid principles. Does it make it easier to learn the craftsmanship on the way, so to say?
Yeah, to be able to be able to write a very good code, you need to follow solid principles. You need to adopt unit testing, and when you do that, you will get very well crafted applications. So yes, the solid principle is a subset of the software craftsmanship, according to my opinion.
Yeah, sure.
If I could get back to the earlier discussion we had regarding boundaries, costs, and so on, the scope of the architecture, so to say. I was wondering, Jenny, if you are the devil's lawyer here for a while, towards microservice and event-driven architecture, what would you say is one of the, I wouldn't say disadvantages, but let's say particular challenges that you as an architect and software development really need to be on top of to solve it as accurate and good as possible?
Well, that's a tricky question. I mean, you're always going to have to understand, and that's if you're building a microservice or other architecture as well, that the scope is going to change eventually. But I mean, in terms of moving from what previously been synchronous to maybe asynchronous, is that when you talk to the product owner and the people designing that, you're not gonna get the response right away. We don't know when we're gonna get the response, but we know that it's gonna happen. So like design for that you're gonna get a notification when something has been updated, rather than okay, when are we going to get it? How long is it going to take? It's like, we don't know. It could take short, it could take a long time. All you know is that we're going to take care of it and we're going to notify it when it has come back. So I think that, and then when you like decouple it more with functions and app services, and then maybe consuming the data from another data source. In terms of integration tests in different environments, you also have to think about how you do that in a way so that you feel like the code that you have up and running, you have integration tests covering all parts, and that you have insight into the status of the service right now.
That was one of those like crucial parts I was wondering, exactly testing, like dividing bigger problems into sub-problems.
Yeah.
That's the purpose with microservices, having some sort of domain architecture-based. This like big problem don't have to solve everyone else. You can divide them, but that does make it more complicated while running tests and so on. Unity tests and for instance.
I mean, I guess you think about it in a different way. As I said, there are many other services, or several more services involved, and maybe you want to like test the entire flow, like the communication. Like I said, let's say that you receive a request to update something, and then you send it. It goes via service bus to a function, which sends it to an on-prem app service, and then communicates back by another worker, which updates the state. So maybe for some cases you want to try like the whole round trip, but other cases not. So yeah, it's you have to think about it.
It is a bit trickier to write test and integration test when you work with microservices. And according to my opinion, you need to add more tests in your pipelines instead of writing. Of course, you should write unit tests as well, but you need to implement a lot of integration testing in your pipelines as well. And this, before you realize how to do this is quite tricky. I remember the first time I did this, it was, I didn't do the right things the first time. And one other thing that, if we leave that question, and I go back to the question before, one thing I struggled with the first time that I started with microservices was performance, because we saw the microservices as just external functions that we called in our existing code and just looped through and called them like 1,000 times. And when you do it this way, it won't be so efficient to have microservices. So you need to think of the architecture in a completely different way to get the performance parts in place.
And as we talked about earlier, the scope of the microservices. I mean, if you have split them, let's say, into 5 microservices, and the one calling them have to make 5 calls to each, which are also communicating with each other, then maybe you have done something wrong.
So we have a question from one of the viewers. What some counter arguments you have encountered from the software teams waiting to keep the legacy structure and wanting to keep the legacy structure, and how did you convince them to think otherwise and move to cloud or Azure? Oh,
that's also a big and rather tricky question. When I work with teams, I usually, in my talk, I mention this concept about target conditions. So I work a lot with those target conditions and try to paint some kind of bright futures for all the developers, so they feel comfortable with this future. And then, as I said before, we cut the problem in smaller pieces and take one piece at a time. And when you have those parts, the target condition and those proof of concepts or smaller pieces to implement, I haven't actually had any problems to get the developers on board on this journey. Maybe this was a bit of an unclear answer, but...
No, but I think you're onto something, because I think the one, like planning for the architecture, I think it's important that you also interact with the ones that are going to realize it and understand the benefits and why are we doing this, because otherwise it's just someone telling you to do something in a manner that you haven't done before and you don't understand why, and it feels maybe scary and stepping out of the comfort zone. So
yeah, this is some kind of ivory tower approach, that the architect sits in the tower and just look out over the landscape and goes down to developer teams and said, do this and do this and do this. And then
you're doing it wrong.
Yeah, exactly. Then they climb back into the tower. So I think you need to attend in a daily work, be a part of the team, and show all the members of the team that this is the greatest idea since sliced bread came.
So when cutting it to pieces, is it within an application or is it in the application landscape? And what kind of, how do you do to prioritize among the smaller pieces together with the team?
This is also a tricky question, and the answer is it depends on the application. I think when you have a monolithic application, all the developers know where are the parts of these monolithic applications that is the most hard.
Painful.
Yeah, the most painful.
To transit or to transform?
Both. To work with right now. And I think it's very easy to convince developers that don't want to move from these monolithic applications, that if we take this little part of this application and decouple it and put it somewhere else, then you can get all the developers on the train. And when you have decoupled it, it doesn't matter if you deploy it to Azure or on another server. But of course, as a cloud architect, I want to deploy it into Azure. But I think you need to work with this decoupling first.
And spend some time on the first decoupling, because then it can be like a plug, like everybody understands why and how we have done this, and then we can start pulling out more.
Yeah.
Great.
Another question coming in here from Gustav. How did you identify and forward all events from the legacy system? And how did you assert that all relevant events were indeed forwarded to the new system? That's a good question.
Well, since we started decoupling one function from the old system, we started out by setting up a new topic where the owner of the application only started sending the events which we were interested in from our new requirements. So we took it step by step. So we didn't introduce all of the events at once. But so I think we have left out a lot of events which are no longer interesting.
Do you have anything more, Gustav? Do you have any questions on your heart?
No, I thought about this like a topic for microservices, like cut the big problem into smaller pieces.
Yeah.
That may be the slogan
Yeah.
for this way of thinking.
Maybe we should adopt that from now on.
Yeah.
Cut it into pieces. Make it worthwhile.
Yeah.
Good. So with that, if there are no more questions from the viewers, I think we maybe wrap it up. So is there anything?
No, it was only Gustav added here. I assume that the legacy system did not use messaging. Well, did it? Or
I think parts of it and parts not.
Okay.
And maybe we now have some more insights for the next meetup in this series. We can focus more on messaging and then how we can solve those kind of problems, and maybe some...
You never know with the cloud transformation series.
No.
That's for sure.
That's for sure. So with this, we'll wrap it up, and we thank everyone who's been watching. Please keep an eye out in our Cloud Transformation Meetup group for upcoming events. And thank you very much for joining us.